Let's talk about this problem for a little bit. We have a drug that's infused through the body at a rate of 100 milligrams per hour. Total amount of the drug in the body is Y, right? So that's where, and in steady state, Y is 200 milligrams, right? And we have a total blood volume of 5 liters. And it's cleared from the body in a single exponential process. All right, so at noon, we're going to pull the line, turn it off, and we need to determine what is Y of t, the amount of drug in the blood as a function of time, so that we can get to what is the clearance of the drug. All right, so where do we start? Well, equation 2.25 is a great place to start. That's where we're going to get dy dt is a minus by. Now in this problem, unlike the previous problem, y is the amount of the drug, not the concentration. So when are we going to be in steady state? All right, we're in steady state when dy dt is 0. That defines steady state. So dy dt equal to 0 means a minus by is 0, which means y is just a over b. Well, we know y. All right, let me just solve this differently, because what we don't know is b, right? The rate at which, the decay rate. B is a over y. Well, we know what y is at steady state. Y at steady state is 200 milligrams. What is what is the amount that's being put in? Right? What's the rate at which new drugs are coming in? So we've got 100 milligrams per hour coming into the body and maintaining a concentration of 200 milligrams. So 0.5 per hour is our decay rate. 0.5 per hour is our decay rate. So this is the rate at which drug is leaving the body. And this makes complete sense, right? We have, we're adding in 100 milligrams. We're maintaining 200 milligrams. Over an hour, we add in 100 milligrams. And if we're losing half of what we have every hour, and we're adding in exactly half of what we have every hour, we're at steady state. So the next question is, what happens once we turn off the drip? All right. Once we turn off the drip, well, now we've got a decaying exponential. Oh, all right. Y is going to be y naught e to the minus bt. And that, in terms of clearance, is y naught e to the minus k over v t. Right? And the clearance is K, and the V is simply the blood volume. So we've got B is K over V. We need the blood volume in terms of cubic meters. And so let's get K is BV, which is 0.5 per hour, times, and the blood volume of 5 liters is 0.005 cubic meters. And now we have our clearance, 0.5 times 0.005 cubic meters, to get us to cubic meters per hour. And let's instead express this in liters. So 2.5 liters per hour is the clearance we have for this med. Hopefully this helps.